We've known for a little while that Mars has water stores trapped beneath its surface. In 2015, the MARSIS mission was able to identify a 20-kilometer wide subsurface lake beneath the Southern Icecap. And now scientists have discovered evidence for multiple lakes beneath this region. But here's the problem. These lakes are all in areas where it would be far too cold for them to remain liquid. We're going to talk about the new scientific finds, as well as the questions they raise. But first, be sure to drop me a like, comment down below, smash that subscribe button, and ring that bell to never miss a video. I'm Eric Malachite, author of Echoes of Olympus Mons, and this is ScienceGet. More than 30 years ago, the Martian polar caps were the catalyst for a decades-long debate over whether or not there was water on the red planet. Back in 2015, the presence of liquid water on Mars' surface was suspected, but up until the launch of MARSIS, which stands for Mars Advanced Radar for Subsurface and Ionosphere Sounding, there wasn't any direct observational evidence for it. Now, MARSIS was outfitted with a low-frequency radar instrument that allowed it to survey the Planum Australe region in Mars' southern hemisphere. The instrument uses radio echo sounding, or RES for short, which is very similar to ground-penetrating radar. RES operates at frequencies in the MF, HF, VHF, and UHF portions of the radio spectrum, and the technique is often referred to as ice-penetrating radar, because it's been used here on Earth to gather radar profiles of our poles, icebergs, and ice sheets. This type of radar causes a unique interaction between ice and water-saturated sediments, which produces bright radar reflections that inform researchers whether or not liquid water is present beneath the surface. Radar profiles taken of a 20-kilometer wide area between May of 2012 and December of 2015 showed several anomalous bright subsurface reflections, which indicated that liquid water was trapped beneath the Martian surface. And believe it or not, MARSIS has been working to study the Martian South Pole for 15 years, with nominal science observations beginning in July of 2005. In 2012, a paper by the MARSIS team measured the difference between the dielectric constant of the northern and southern high-altitude regions, citing that it was evidence that the material that MARSIS observed filling the northern basin was a lower-density material, or perhaps an ocean. In 2015, of course, a paper confirmed this. And in July of 2018, 22 Italian scientists reported the discovery of a subglacial lake on Mars 1.5 kilometers beneath the southern polar ice cap and 20 kilometers wide. Back then, we thought this was the first stable body of water ever observed on Mars. But what if it was something else entirely? On Mars, in the southern pole, the South Polar Layered Deposits, or SPLD for short, are stacks of multi-kilometer thick water ice deposits that extend across the land. The composition of the layers of the SPLD are thought to be variations in water ice and dust linked to Mars's tilt, as well as its eccentric orbit, making these landforms truly unique. In the past, Mars had a much lower axial tilt, and snowfall as well as layers of dust slowly accumulated in the region, eventually forming into the South Polar Layered Deposits. Mars and Earth are very similar in obliquity. In fact, while Earth has a tilt of 23.5 degrees, Mars has a tilt of 25 degrees, which is only 1.5 degrees off from being a match. A new paper published in Geophysical Research Letters at the tail end of June claims that there are even more of these subsurface lakes than we originally thought. In fact, two scientists at NASA's JPL in SoCal claimed that they've found evidence for dozens of them, but something truly odd is going on with them. Using data collected from MARSIS's RES instrument, the team behind the paper produced a striking map of the SPLD basal interface, measuring its thickness, volume, and electrical properties. One of the reasons why glaciers on Earth are so ideal for this form of radar is because of their conductivity and dielectric absorption, which is a measurement of the electric polarizability of a dielectric. And a dielectric is an electrical insulator that can be polarized against an applied electric field. The team basically used all of the data that MARSIS has taken since 2005 to improve their model of the SPLD landforms. And what they found was that these subsurface lakes are all in areas that are far too cold to allow for liquid water, even accounting for the presence of high salt concentrations or perchlorates that would effectively raise the freezing temperature. Jeffrey Plout of JPL and co-principal investigator of MARSIS said this in relation to the work. "We're not certain that these signals are liquid water or not, but they appear to be much more widespread than what the original paper found. Either liquid water is common beneath Mars' south pole, or these signals are indicative of something else. But if these radar reflections aren't indicating liquid water, and instead they're hinting at some other liquid substance pooling beneath the Martian surface, what could it be?" If it turns out that JPL's suspicions that these lakes beneath the southern Martian pole really aren't water, what could be lurking beneath the surface? Well, this is purely speculation. Yes, that. But couldn't these lakes be composed of liquid methane? We see lakes of liquid methane on Titan, Saturn's most interesting moon, and although methane is rarely talked about in relation to the red planet, Mars Express actually detected raised levels of the stuff in the northern hemisphere. Now, here on Earth, almost all of the methane in our atmosphere is produced by living organisms, a large contributing factor being cow farts and cow belching. No, I'm not joking. But on Mars, the jury is out whether this is an abiotic process or one caused by subsurface organic life. But what we do know about methane is that it can remain liquid in absolutely frigid temperatures. On Titan, temperatures can get as low as -179 degrees Celsius, or -290 Fahrenheit. But on Mars, the poles can get as cold as -125 degrees Celsius, or -195 Fahrenheit. Not nearly as cold. Part of the reason why there's a debate about whether or not this could be an organic or abiotic process is because of the discovery of Earth's deep biosphere, a subject that I will never stop harkening back to because it's just that awesome. If Mars has such a deep biosphere, then microbial life could be the source of its methane emissions. Alternatively, if those microbes have been extinct for millions of years, then they could have left methane frozen in Mars's upper subsurface, allowing it to escape as a gas today as temperatures and pressure on the surface change. However, if the methane on Mars is abiotic, or rather geological in origin, then it could have been produced by the oxidation of iron, which actually happens in hot springs here on Earth. Another option is that it could have been produced in volcanic processes as well. There is some striking evidence for volcanic activity on the red planet, which we did a video on some time ago. The gases produced by past or potentially present volcanic activity could have then been trapped in solid forms of water, or rather cages, that can preserve methane for eons. These structures would be known as clathrate hydrates if they exist on Mars. Another process that could produce this methane is called serpentinization, which is a geochemical process that occurs when olivine reacts with water when carbon dioxide is present to act as a catalyst, forming a mineral called serpentine. But unfortunately, this process would more than likely require that Mars has active volcanism. Now, most of the sources that I've used to construct this section out only talk about icy blocks of methane frozen in Martian water, or the gaseous methane that's observed on the surface. But I'd be interested to see if it could be possible that these lakes are actually methane produced abiotically, if not from microorganisms, although I admit the latter might be a bit of a stretch. The other option, though, is that this really is liquid water that we're seeing. And the reason why it's been able to remain in liquid form is due to geothermal processes. We've talked about Mars's potential for active volcanism in the past. Most estimates for when the last volcano on Mars had any kind of activity was previously between 3 billion and 4 billion years ago. But recently, we've discovered some evidence that suggests a much more recent volcanic history that also suggests that the planet was habitable far more recently than previously theorized. Another estimate suggested that Mars could have had active volcanic eruptions as recently as 2.5 million years ago, and now scientists have discovered evidence that Mars may still have volcanic activity today, with signs of an eruption that would have taken place as soon as 50,000 years ago. This was accomplished through the use of satellites orbiting Mars. Researchers analyzed Elysium Planitia, a region that is largely composed of featureless equatorial plains. There they discovered evidence for a smooth, dark volcanic deposit about 13 kilometers wide, or 8 miles, which is larger than Washington, D.C. This volcanic deposit surrounds a volcanic fissure that's about 32 kilometers wide itself, or 20 miles wide. And one of these cracks makes up the fissure system known as the Cerberus Fossae. What's interesting about this is the deposit looks totally different from anything else we've seen in the region, or pretty much the rest of the red planet. This feature also resembles older volcanic eruptions found on the Moon and Mercury. One researcher suggested that if we were to compress Mars's geological history into a single day, then this eruption would have happened a second ago, which kind of puts things into perspective. However, the paper concerning these subterranean lakes actually cites that no evidence of recent volcanic activity has ever been found in the southern hemisphere of Mars, and they are right in saying that. But as another point of speculation, thank you, computer, I would argue that if we've detected evidence of recent volcanic activity in the northern hemisphere, then isn't it possible that these lakes could still be heated by geothermal activity from Mars's core? While it's definitely true that Mars's magnetic field is dead, or at least currently collapsed, a 2007 study found evidence that suggested that Mars still had an active molten core, which is amazing because that has not been the narrative even in recent years. In 2007, a study published in Science uncovered evidence suggesting that Mars's core was more than likely still molten. And this is not something that has been ignored over the past decade either, despite what the narrative surrounding the red planet has been. Earth is no stranger to magnetic field collapse though, as we discussed in our video on how a magnetic pole reversal 40,000 years ago led to an extinction event. These periods can leave our planet without the protection of its magnetosphere for tens of thousands of years. And while this is definitely still only speculation, couldn't that also be true of Mars? However, even if Mars's core is still active, it's still possible that the geothermal heat present beneath these south polar layered deposits might still be insufficient to keep these lakes warm enough for them to remain liquid. One reason for that could be that while the core of Mars might not be dead, parts of its outer regions may also be crystallized or hardened. But also, according to a 2019 paper, it would most likely take double the estimated Martian geothermal heat flow to keep that subterranean water from freezing over. And since we haven't seen much evidence of volcanic activity in the South Pole, this may actually be the case. This is awkward though, because some kind of liquid is definitely causing these radar reflections, leaving the researchers involved with this 2021 study scratching their heads. If you dug this content, be sure to hit that like button and comment down below. Do you think Mars's core is really dead? Why? Why not? And be sure to smash that subscribe button, ring that bell to never miss an episode of the show, and check out the Patreon while you're at it. And speaking of which, look at all those wonderful names. Thank you, patrons. I'm Eric Malachite, and I'll see you next time.